In this lesson, you will learn how to solve radical equations. Radical equations are just equations with roots. The goal is get the root by itself, so move everything to the other side, and then you can get rid of the root by, if it's a square root, you square, if it's a cube root, you cube, if it's a fourth root, you raise it to the fourth power, and so on. If you have more than one root, you need to isolate at least one of the roots and then do the same process, and then you'll have to isolate the other root after. That's a more advanced problem like number 5. I did put one on there in case I have an advanced student, but it typically does not show up in Algebra 2. The last thing you need to do is you need to go back and check your solution. Some of these solutions you solve it correctly, but they do not work. They're what we call extraneous solutions. So you can only use the ones that work. Let's get started. Number 1, I have a square root, so it's already by itself. The inverse of a square root is a square. So square this side and square that side. The square will cancel the square root. That's what you want. So we have 2x equals 4 times 4 is 16. Now I just have a normal equation to solve for x here. Divide by 2 to get x equals 8. But let's check it. To check it, you go back to the original problem, which was square root of 2x equals 4. I'm going to plug in x right here. So I have square root of 2 times x, which is 8. It says that should equal 4. That's 8, not 18. 2 times 8 is 16. Square root of 16 is 4, which equals 4. So that is correct. The answer is not 4, though. It's whatever you solve for x. Okay, number 2 here, I need to get this by itself. You see how the negative 2 is not under the square root, it needs to go to the other side. So add 2 to both sides. We will get square root of x minus 3 equals 0, because that's going to go away. No, I'm sorry, it does not equal 0. 0 plus 2 is 2. Now that the square root's by itself, I'm ready to get rid of it by squaring this side and squaring that side. That will cancel out. So I have x minus 3 equals 4. Add 3 to both sides to get x equals 7. Go back and plug it in. The original equation was x minus 3, so 7 minus 3. Then we had minus 2 equals 0. You need to see if this side will equal 0. 7 minus 3 is 4 minus 2. Square root of 4 is 2 minus 2, which equals 0. That doesn't always work. So let's say I plug it in and it doesn't work. I would say it's no solution. Hopefully we'll run into one like that before I'm done. All right, number 3. This is a cube root. It's already by itself. So to get rid of a cube root, you cube both sides. That will cancel to get 6x equals negative 3 times 3. Negative 3 times negative 3 is negative 27. Divide by 6. Simplify this. 3 goes into both of these. You'll get negative 9 over 2. To plug this in, okay, I have the cube root of 6 times negative 9 over 2 to see if this will equal negative 3. 2 goes into 6 3 times. So now I have the cube root of negative 27, which does equal negative 3, so it works. Okay, number 4. This is a plus 1, so subtract 1 on both sides. We'll get 13 minus x equals x minus 1. That's a 13. Square both sides, not that the square root's by itself. That's going to cancel to get 13 minus x. On this side, this is a binomial, so write it down twice. You're going to have to do some algebra on this one. That side stays the same. On this side, go ahead and FOIL. X times x is x squared. X times negative x is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is a positive 1. Next, we will combine like terms on the right side. Negative x minus x is negative 2x plus 1. So now how do we solve this? If you see a squared or an exponent, you need to factor, okay? Or use quadratic equation if it's squared, or any of those other methods we learned in the quadratic equation section. One of the things you need to know is it must equal 0. So this needs to come to this side. So the 13, I need to subtract 13, put it under its like term. I also need to move the x, so add x. So that's 0, that's what you want, equals x squared. Negative 2 plus 1 is negative 1. 1 minus 13 is negative 12. Remember, this is a trinomial. We factor trinomials by product and sum, okay? The product is the last number, which is negative 12. The sum is this middle number, which is negative 1. So you want two numbers that multiply to get that, and the same two numbers must add to get that. We could do negative 4 times 3, that's negative 12, and if you add those, you get negative 1. So since there's no number here, I can plug those in, x minus 4 and x plus 3, but I still need to solve this. Okay, I'll just come up here. So I have x minus 4 equals 0 and x plus 3 equals 0. Add 4 to get x equals 4. Subtract 3 to get x equals negative 3. You must check both separately. So let me go ahead and rewrite what the original equation was. That was what it was. So let's start with 4. Plug in 4. We have 13 minus 4 plus 1 equals x, which is 4. So 13 minus 4 is 9. Square root of 9 is 3, and 3 plus 1 is 4. That's great, that works. So this is one answer. Same way, plug in negative 3. So I have 13 minus negative 3 plus 1 should equal negative 3. 13 minus negative 3 is 16. That's the same thing as saying 13 plus 3. Square root of 16 is 4. And these do not equal. So this is a really good example of where you must check your work. So this is not a solution. The only solution to number 4 is x equals 4. Next we have number 5. I cleared my board so we can have more room. Okay, so I need to isolate either this one or this one. You always want to leave it positive, which it would in either one. So let's subtract this. So I'm going to move this to the other side. You subtract the whole thing. This one's going to be a little bit more advanced, like I said. I don't know that it's taught in a lot of algebra too. So I'll bring x plus 3 equals, because that's gone, 3 minus square root of x minus 5. Okay, so now I want to isolate this x root, so I'm going to square this side. If you square this side, you must square that side. Here they will cancel, so I have x plus 3. On this side, you cannot cancel that because it's all together. So remember, this is a binomial, so write it down twice. This is where the tricky part comes, how to work that out. This side, you just drop that down. Okay, we're going to do the same concept of FOIL. So 3 times 3 is 9. 3 times negative square root of x minus 5. The 3 is not under, so it's just going to be a minus. Bring the 3 first and then keep the root. You got to do the same thing here. A minus, bring the 3 first and keep the root. And then here, okay? Negative times a negative is a positive. Remember how we said square root of 5 times square root of 5 is 5? Same concept. A square root times a square root, you'll get the same thing. So you can drop the square root and get x minus 5. If this would have been a minus, I would have put that in parentheses to distribute my negative. Now I just need to combine like terms. I can do 9 minus 5 to get 4. I can do these two. Negative 3 minus 3 is negative 6. Keep the root part the same. Then drop your x. Okay. Now, where do I go from here? I have a root. You have to do the whole thing all over again. Isolate this root. So everything around the root must go. So let's start with this 4. Subtract 4, put it under there. I'm going to go ahead and do this x. Subtract x, subtract x. Let's do that part first. X minus x is 0. 3 minus 4 is negative 1. That's going to cancel. Bring this down. That's going to cancel. Look how much cleaner it already looks. Okay, now I need to divide by negative 6. I'm surprised we have a fraction. Normally you don't have a fraction, but it's okay. Negative and a negative is a positive, and then I have that. Last step is just get rid of your square root. So square this side, square that side. When you square this side, square the 1 and square the 6. So that would be 1 times 1 is 1, 36 times 6 is 36, equals x minus 5. Okay, now I just need to add 5 to get my x. So when you add 5, we're going to do common denominator. Yeah, like I said, normally there's no fraction here. I hope I didn't do something wrong, but I don't think I did. 1 over 36 plus 36 times 5 is 180 over 36 equals x. Add, so you get 181 over 36. To check this, I would plug it in here. Okay, so let's plug it in to see if it works. X is 181 over 36 plus 3. I'm just plugging it into the original equation. Okay, so now I have, okay, common denominator again. So times 36 times 36, this will give me 36 times 3 is 108 plus 181 is 289. Yeah, this was a very complicated one I chose. Normally they're not this bad. Plus, same thing here, over 1 times 36 times 36. This time I have 36 times 5 is 180. So 180 minus 181 is 1. So I have 1 over 36 there to see if equals 3. All right, get these square roots. Square root of 289 is 17. Square root of 36 is 6. Plus square root of 1 is 1. Square root of 36 is 6. Add. 17 plus 1 is 18 over 6, which, look at that, it's actually 3. I actually thought I had made a mistake because of so many fractions. This is very advanced, like I said, but it's good for people who would like to do the advanced way, so it works. So what's my answer? My answer is what I solved for x. Okay, where did I solve for x? 181 over 36.